Okay, this is the sheet that is labeled 9829. It was given out on the day of the blackout, so I guess that was Thursday. And you were supposed to finish it for homework, so I realized you should know these answers before the test on Monday, so that's why I'm doing this now. So for number one, it's saying that x of t equals this. And how many times does the particle change direction? So the particle is going to change direction when the velocity equals 0. So the velocity is just going to be the derivative. And then we're going to take that and we're going to set that equal to 0. Okay, and we can divide each term. Well, you could divide, or we could just go right to factoring. I guess let's just go to factoring. We'll factor out a 5t squared. Okay, so if we set each of these equal to 0, you're going to get t equals 0. And then when you set this one equal to 0, okay, so you're going to get that. Okay, so first of all, time can never be negative, so we're definitely going to take the negative one out. That can't be. At t equals 0, there's no way that a particle can, at 0, move and stop and turn around, because it wouldn't be 0 anymore. So the only possibility is the radical 3 over 4. Okay, so I'm going to erase this. Okay, so we're going to just consider t equals radical 3 over 4, which is radical 3 over 2, actually. Let's simplify. Oops. Okay, so it changed direction. The velocity equals 0, but we also have to make sure that the acceleration does not equal 0. So the acceleration is just the derivative of the velocity, which will be this. Okay, and then we're going to put radical 3 over 2 in for t, and we need to just double check that. Now, of course, if you're running out of time on the AP test, if it was me, I would just guess that it's not going to equal 0, and I would, say that that's the answer. But if you do have time, you really should work it out. Okay, so you're going to get 80 times radical 3 to the third over 8, right? When you do 2 to the third power, you get 8, minus 30 radical 3 over 2. Okay, now I can erase this. Get some room. Okay, so we're just going to multiply straight across. So we're going to have 80 times radical 3 to the third over 8 minus 30 radical 3 over 2. 2 goes into 30 15 times, so this becomes a negative 15 over radical 3. 8 goes into 80, whoops, 10 times, so you're going to get 10 times radical 3 cubed. Okay, there's no way that this is going to equal 0. So therefore, that the particle did stop and change direction at t equals, what did we say, radical 3 over 2. And the question is saying how many times? So the answer would be A, 1 time. Okay, for question 2, that one we already did in class. So I'm going to go to number 3. Okay, so for number 3, we're given an x of t again. And when is the speed of the particle increasing? So we said that the speed will be increasing, so I'm just going to write this down so in case you don't have it. So the speed is increasing when v of t and a of t, when velocity and acceleration have the same signs. Okay, and so the question is not asking, is it at a certain time increasing? It's just saying, is there any time when the speed is increasing? Okay, so we're going to have to do a little bit of work here because we have to figure out what those intervals are. So the first one we're going to do is we're going to find v of t. I'm just thinking maybe I should go to the next page and have more room. Okay, so x of t was this. V of t will be this. Okay, we're going to set that equal to 0 because how else are we going to get any sort of intervals, right? And we can divide every term by 3. Okay, and then we'll factor. And we get 2 solutions. Okay, and now we're going to do the same thing for the acceleration, which is just the derivative of the velocity. And we'll get that, and we're going to set that equal to 0. Okay, so we have 3 different answers, t equals 1, 2, and 3. So we're going to make a wiggle graph, and I'm going to need some room to do that. So I want to keep my velocity and acceleration, so I'm going to do it over here. So it's t equals 1, 2, and 3. And we're going to have to check velocity, and we're going to have to check the acceleration. Okay, so you're just going to take values on either side of these values 1, 2, and 3, and first you're going to plug them into the velocity, which is over here. So for example, if you take 0 and you put in there, you're going to get 9, which is positive. And then you'll try 1.5, and you'll try all these different values, and this is where knowing how to use the table really comes into use. It'll make it very fast. So you're going to get these signs. And then for the acceleration, you're going to get these signs. So the question is asking, when is the speed increasing? So the speed is going to increase when the signs are the same. So that's going to happen here, and it's going to happen here. So it's happening from 1 to 2, and then it's going to happen from 3, well, to infinity. And that is going to be choice C. Okay, so this is number 4, and question 4 is asking you, when is the velocity decreasing? Okay, so you were given the original function, and the velocity is going to be this. Okay, so when you bring this 3 over here, the 3's will cancel, and you'll get 16t. Okay, so we want to know, when is this decreasing? So think about, I'm just going to set a little aside. So if I want to know when f is decreasing, wouldn't I know if f is decreasing if f prime is less than 0? So if I want to know when this thing is decreasing, then wouldn't I want to know when v prime is less than 0? But v prime is really the acceleration. So the question really is, when is a less than 0? When is the acceleration less than 0? Okay, so to do that, we're going to have to find the acceleration. And we get this. Okay, so we're going to need some values to put on our wiggle graph, so we're going to set this equal to 0. We can divide every term by 4. Okay, we're going to factor. And it's going to be 2 and 2. Okay, so let me make some room up here. Okay, so either 3t minus 2 equals 0, which means that t is 2/3, or for this one, it's just going to be t equals 2. Okay, so we're going to make a wiggle graph. Put on 2/3 and 2, and we're going to, oh, I took the acceleration away, let me put it back. Okay, that's acceleration, so we want to test the acceleration. So we're going to take different values. For example, when t is 0, you'll get 16, so that would be positive. T of 1, it will give you 12 minus 32 plus 16, so that's going to be negative. And then if you do like t of 3, you're going to end up getting a positive. Okay, so our goal was to find out when is a less than 0. So a will be less than 0 from 2/3 to 2. And if you look at all the choices, that's going to be choice A. Okay, and that completes the sheet. So if you were absent and you don't know how we got the graph problems, please ask someone in the class because we did go over this.